look at anything again, it'll be there. All right, so the second conic section we have is called an ellipse. So remember how I said they're called a conic section because if I have a cone, here's my cone. The other day we sliced it exactly parallel to its base and got a circle. Well, this time if we slice it, we're going to slice it at an angle, which is going to take that circle and stretch it. So it's what you're used to calling it is a oval. The official math term is ellipse. All right, so I want to tell you what an ellipse actually is, or some of the things about an ellipse. If I have an ellipse, right here in the middle, of course, is the center. Whatever direction it's stretched further, so in this case it's stretched side to side, the end points, when it's stretched side to side, are called the vertices. The short direction that it's stretched, those two sides exactly across, are called the co-vertices. This whole length of our ellipse is called the major axis. The short side, it's going to shock you, is called the minor axis. Sometimes it's going to ask for the length of the minor axis. The other thing I want to add in here is from the center to the vertices, the letter we use is A. From the center to the co-vertices, the letter we use is B. All right, so that being said, let's talk about what the equation is going to look like. Okay, so my equation, when it opens up side to side, again, I want to remind you, if it looks like this, from the center to the outside is A, and from the center to the top is B. All right, so our equation is going to be x minus h squared over a squared y minus k squared over b squared equals 1. All right, so if I ignored the a squared and the b squared, we have a circle, right? The equation would be for a circle. This a squared and b squared on the bottom is what stretches our circle into an oval shape. All right, so the only difference is when it stretches this direction, or it goes up to down, up to, that was a terrible P, to down. Again, from the center to the long way it's stretched is A, and from the center to the short way is B. So how does that change it in our equation? Well, we have x minus h, which represents the center, of course. Over on the x-axis, this is now the b squared plus y minus k squared over a squared equals 1. An ellipse always, always, always is equal to 1, and it always has a plus in the middle. All right? So I think the easiest thing to start with is graphing some. Let's talk about graphing them. All right, so example number 1. I want you to identify the vertices and co-vertices, then sketch the graph. All right. So let's say I have x squared over 36 plus y squared over 16 equals 1. All right. The first thing we're going to look at is the center. The center, just like a circle, in this case we have nothing in with x and nothing in with y. So in this case our center is at 0, 0. All right. Underneath x, we have 36, which means if we square root that, our a value is 6. If I square root 16, my b value is 4. So the easiest thing to do when you're graphing is first plot your center. In this case, it's here. Underneath the x, right? So on the x-axis, we're going to square root this, and we're going to go right and left from our center, whatever that value is. So I'm going to go 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4, 5, 6 to the left. Those are my vertices. It's the way it's stretched longer. I'm going to go underneath my y, so on the y-axis, I'm going to go up 4 and down 4. And then, here's the tricky part, we're going to try and connect our 4 dots. All right, so that's the graph. Our vertices, remember, are the long way it's stretched, so it's at 0, negative 6. No, let me try that again. Negative 6, 0, sorry, and 6, 0. Our co-vertices are up 4 and down 4, so those are at 0, 4, and 0, negative 4. Yes, you can absolutely write it as plus or minus 6, 0. Absolutely. When the center is at 0. Okay, let's try another one. Again, I just want you to graph it. I want you to get very comfortable with graphing it. So if I graph, let's say again I have x squared over, let's go 4, plus y squared over 25 equals 1. All right, first thing you look for is the center. Again, on this one, our center, there's nothing new with x and y, is at 0, 0. All right, so I'm going to plot our center. Okay, underneath x is 4. If I square root that, I get 2, right? So that means on my x-axis, I'm going to go 2 to the right and 2 to the left. Under y is 25. If I square root that, I get 5. So I'm going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. And I'm going to connect my dots. All right. So now, if I wanted to know where my vertices were at, that's the longer way it's stretched. So it's here and here. So I have 0 and plus and minus 5. My co-vertices are the short way, which from the center are plus and minus 2 and 0. Any questions so far? Seem pretty easy, especially when the center's at 0?
Good.
All right, cool beans. So let's try moving our center a little bit, though. Okay? Let me get in the page. All right, so let's try this. Example number 3. On example number 3, I want you to state the center, the vertices, and the co-vertices. Right? And then, of course, I want you to graph. And graph. All right, so let's see, we have x minus 1 squared over 16 plus y minus 2 squared over 25 equals 1. All right. So if you look at this equation, you can tell because the bigger number on the bottom that this is going to stretch up and down, okay? The bigger number is under y, so it's going to stretch on the y-axis up and down. Let's graph it to begin with. So first I need my center. My center is what's in with x and what's in with y. Remember, this is my h and my k, just like when we had a circle. So my center is at 1, 2. All right, so we're going to start by plotting our center. I'm going to go to the right one and up 2 and put a dot. All right, there's my center. Now, from my center, I'm going to go to my x. Underneath x is the 16. If I square root 16, I get 4. That means I'm going to go to the right and left 4 from my center. So from my center, I'm going to go 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. Under my y, I have 25. If I square root 25, I get 5. That means I'm going to go up 5 and down 5. And 1, 2, 3, 4, 5. And then I'm going to connect my dots. All right, so that's graphing it. I honestly think graphing it is easier and then stating the vertices and co-vertices afterwards. So let's start with the vertices. Because this stretches up and down, I mean what this point and this point are. So my points are 1 and it went up 1, 2, 3, 4, 5, 6, 7. Right? And my other one is at 1 and negative 1, 2, 3. All right, my co-vertices are the 2 on the side. So I went to the right 4 and to the left 4. So my first point is at, let's do this side first, negative 3, 2. My second point is at 5 and 2. So my center should fall right in the middle. If I add my x values together, negative 3 plus 5, I get 2. Divide by 2, I get 1. That's exactly where my center should be. I can always check to make sure I have the right point. Try another one of these. Exactly what I did here is exactly what you have to do for 3 and 4, and 5 and 6, and 7 and 8. So this is actually 3 through 8. Okay? All right, let's try another one. Example number 4. All right, I want the center, the vertices, the co-vertices, and the graph. So let's do x plus 1 squared over 16 plus y minus 4 squared over 4 equals 1. So just looking at the equation, you should know that this is going to stretch side to side, right? Because the bigger number is on the x-axis, or underneath the x. So let's start with our center. Our center is at negative 1, positive 4. All right, so let's graph our center. Negative 1, 1, 2, 3, 4, right here. All right, on our x-axis, underneath the x, we're going to take the square root of 16, which is 4. So I'm going to go to the right 4 and to the left 4. So 1, 2, 3, 4, and 1, 2, 3, 4. I know I'm stretching it this way, so I can do my vertices right now if I want, or I can wait till after I graph it. If we do the vertices and we stretched it on the x, I'm going to add 4 to my negative 1, and I should get 3, 4. If I add or subtract 4 from my negative 1, I should get negative 5, 4 as my 2 vertices. All right, this one and this one. Do up and down underneath y. If I square root 4, I get 2. So that means on the y-axis, I'm going to go up 2 and down 2. Those are my co-vertices. So it's at negative 1. If I add 2 to 4, I get 6. If I subtract 2 from 4, I get 2. You can think of it that way also, or you can just draw it and write down the points. I'm okay either way. Questions so far? Anybody at all? Okay. All right. So let's try this example then. Example number 5. This time I want you to write the equation. And I'm going to give you some information. Let's start with, let's say we have vertices at 0 and plus and minus 5, and co-vertices at plus and minus 2, 0. All right, so we're going to write the equation for this. Sometimes it's easier to sketch what this means to begin with. So I have vertices at plus and minus, or 0, plus and minus 5. So 1, 2, 3, 4. Here's one vertice. 1, 2, 3, 4, 5. Here's my other vertice. I have co-vertices at -2, 0 and +2, 0. Here's my picture. Oops, I kind of missed my dot on that side, but all right, so I need to write my equation. First of all, I've got to figure out what the center is. What is the center to this ellipse? My center is at 0, 0, right? At the origin. So I know that I have x, technically minus 0 squared, or x squared, plus y squared equals 1. That's what I'm going to start with, right? My distance on the x-axis from my center to either end is 2. So underneath x, I'm just going to square that to 4. On the y-axis, from the center to either end, is 5. So I'm going to take 5 and square it, and I get 25. That's my answer on my equation. Try another one. Let's say we have vertices at plus and minus 10, 0, and co-vertices at 0 and plus and minus 3. All right, so which way is this one stretched? This is stretched longer on the x, right? If you think about it, if we graph it, we're plotting 10, 0, and -10, 0. Our co-vertices are at 0, 3, and 0, -3. So this is stretched side to side. Again, where's my center fall? Very good. So when we write our equation, we're going to start off with x squared over something plus y squared over something equals 1. All right? Now, underneath x is the distance from the center to either end of our ellipse on the x-axis. That's 10, and we square it. So underneath x, we get 100. Under y is that b value squared. The distance from here to here is b, and we square it. That's 9. That's it. Do one without a center at the origin. Okay? Actually, let's back up just a second. So, when you're doing your worksheet today, the 2 like this, this is numbers 9 through 12. Your centers are all at the origin. You're writing your equation with the centers of 0, 0. Okay? Last 2, whoops, let's go this way, sorry. Last 2. Example number 6. This will be numbers 13 and 14. Your center will no longer be at the origin, so you're going to have to figure it out. Okay? So, let's say I have vertices at 17 and -7 and 3 and -7. Then I have co-vertices at 10, -4 and 10, -10. All right, so we have to figure out what our center is to begin with. Our center. Easiest thing to do is look at your vertices. What does not change in your vertices? The y value doesn't change It stays -7. So guess what the y value is for our center? -7. Yeah. In our co-vertices, the value that doesn't change is our x value. And guess what? Our center is 10. All right. So when we write our equation, we're going to start with the center. On top, we have x minus our h value of 10 squared over something plus y minus the -7 or plus 7 squared over something equals 1. So the center shouldn't be tough. Pretty straightforward. This is where it gets a little bit tougher. Okay, so, and I'm going to kind of write it up here. My center for x is at 10, right? So I want between 17 and 3, 10 falls right in the middle. What is that distance between them? And either from 17 to 10 or from 10 to 3. That distance is 7, right? The distance from here is 7. So I'm going to take 7 and square it and put it underneath x. So that's 49. All right? Same thing when I talk about the y value. My y value, the center on my y values is -7. So how far is it from -4 to -7 or from -7 to -10? It's just 3 units, right? So I'm going to square 3 and put it underneath the y. That's it. Let's do it again. All right, so if I have, let's say this time I have vertices at, let's go with 6, 9, and -12, 9. And let's say we have co-vertices at -3, 12, and -3, 6. All right, so first we got to figure out our center. Our center. So in our vertices, the value that does not change in our vertices is the y value. So our center for the y value is 9. In our co-vertices, the x value doesn't change. So our center for the x value is -3. All right, so writing our equation, it is x minus -3, so plus 3, squared over something, plus y minus 9 squared over something equals 1. We got to figure out what those a and b are. What goes on the bottom? All right, so we're going to start with our x value. On our vertices, from -6 to -12, -3 falls right in the middle of the two. What is the distance from either end? So get from -3 to 6 or -3 to 12 is 9 units, right? That is a 9 at the top there. There we go. So I'm going to square 9 and put it underneath my x. So 9 times 9 is 81. In between 12 and 6 is our center of 9. So again, what's the value from 12 to 9 or from 9 to 6? That's just 3. So we're going to square 3 and put it under our y. That's all there is. Now, I have one other thing I want to mention. On problems on your worksheet, I have a typo. I apologize. For numbers 1 and 2 on the worksheet. Okay? It asks you to identify vertices, and it says foci. We're not doing the foci till tomorrow, so I do not want you to worry about that. Identify the vertices. That's the long way it's stretched. Okay? Anybody have any questions? Do you guys have a meeting right now? Or you have a meeting you got to get to? Or no? Okay, well, I was just wasn't sure. I'm losing track of what some of the other teachers are doing anymore, so they're kind of all over the place. That's why I like it at the same time every day, and you know what's going on. All right, so we're going to talk about ellipses today and tomorrow. So we're going to do more on ellipses tomorrow. So you'll get used to it, and then we're going to try a new conic section on Wednesday, and then Thursday we're going to tie it all up, and then we'll be on Christmas break. Isn't that exciting? And then, and then hopefully, fingers crossed, we're going to be back together after that. I cannot wait. All right? So your worksheet should not take you very long, especially once you get into the groove of it. All right? You guys, if you have any questions, let me know. I'm going to post this video, the notes, and your assignment's already on there. So I want to remind you, progress reports are coming out. Make sure if you have any missing assignments you want to get turned in, you get that done. And if you haven't taken your test yet, you better get on it. All right? Including the review. Some of you didn't do the review but did the test. So make sure you get that done too, because that's 10 points. All right. I miss you guys. Can't wait to see y'all. Have a great afternoon.